Okay, today we've got EE5 and EE6, slope, proportional relationships, and some y equals mx plus b stuff. All right, page 10. From now on, we can use calculators. That's good. So you can take your calculator out. Number 1 says to graph the following scenario. Tom can climb 20 feet for every minute. Well, we should start by labeling our graph. Okay, usually time is going to go on the x-axis, so let's label this, and of course I'm going to call this my y-axis, and this my x-axis. Make that a little straighter. Alright, so the x-axis will be minutes, and the y-axis we will call the other thing, which is feet. So let's see. We need to go 20 feet every minute. So if we want to do a few of these, maybe we can do 1, 2, 3, 4, and so on. You don't have to label the entire graph unless you want to. If we're going to go 20 per minute, it doesn't really matter what you call this other side here, the y-axis. I'm going to go 20 here, and this would be 40 then, and 60, and 80, 100. Again, you don't have to label everything like I was doing there, as long as we just get the gist of what you're graphing. I'm going to use a different color to do this. Well, if I go 20 feet every minute, then I probably started off at 0. And in fact, we know that because we are doing proportional relationships on this page, and you guys know that proportional relationships go through the origin. Okay, so then we have, after 1 minute, if we go 20 feet per minute, I go up to 20. So then after 2 minutes, I would go up to 40, and 3 minutes, I would go up to 60, and so forth. Okay, so that's that graph. Of course, this is continuous, so we could connect our dots. Like that. Okay, number 2. The following equation models Bob's climbing ability. We have y equals 1100x. Y is the distance in feet, and x is the time in hours. Okay, that's similar to our graph. We had y was the feet, and x was minutes. This one is x in hours. Okay, that's different, a little bit different. Who climbs faster, Tom, which is the guy from the original, or Bob, here? Well, let's see. Bob is over here. We know his equation is y equals 1100x. So he can climb this many feet per hour. So 1100 feet per hour. So if we take Tom's information, that comes from here. Tom, it says here, right? We're going to go over here. There's Tom, way over there. His information comes from the graph. Well, we know he can go 20 feet every minute, but we have to figure out how much that is per hour. Well, if there's 60 minutes per hour, let's write that over here, 60 minutes per hour, and we have to figure out, okay, so 20 feet per minute. Does that mean he can go more or less in an hour? If he can go 20 feet per minute, obviously he can go more than that per hour. So we're going to take the 60 and make it bigger. We're going to make that 20 bigger by multiplying it by the 60 is what I'm trying to say. Okay, so we're going to take, he originally did 20 feet per minute, but we're going to multiply that times 60 to get how many feet per hour. And 20 times 60 is 1,200 feet per hour. So now we can compare Okay, we can compare our 1100 and our 1200. So who goes faster? That would be Tom. And I'll even do a little arrow there. Okay. All right, number 3. Create a graph using the following information. We have time is in hours, distance is in miles. So let's label this. Time almost always goes on the x-axis, and of course, since it's at the top of our table, we know that's our x. So this is going to be hours, or you could put time, that's fine. Oh, and miles, or distance is fine too. All right, so after 2 hours, we're at 30 miles. So let's just go ahead and label it, go by ones here. 1, 2, 3, 4, 5. I'm just going to keep going here. 6. Okay. So label that axis, label the other axis. We can't really go up by ones on the other side though, because we got to get up to at least 75. I think I went by tens when I did it before. Let's see. 10, 20, 30, 40, 50, 60, 70. That'll get me to 75 at least, right? Okay, so we're going to graph these points. So 230, you guys know how to graph. 230, 4, 60, and 5 is 75. And we know it's proportional, so we know it goes through the origin. If that helps you to graph it, we're going to go ahead and connect our dots because time is continuous. There it is. All right, we're going to do number 4. Which equation represents the table in question 3? So we're looking at this question here. So what do we know? We have to find the slope of this table. So the slope is, of course, the change in y over the change in x. So if this is my first x here, my second x, and my first y and my second y, I can just plug those in. y2 minus y1 over x2 minus x1. So our slope is going to be 30 over 2, which is 15. And obviously there's no y-intercept here because this page talks about proportional relationships, which has a y-intercept of 0. All right, page 11. What is the slope of the hypotenuse of triangle 1? What is the slope of the hypotenuse of triangle 2? Well, as you can see, they both lie on the same line, which means they have the same slope. But let's check it out just to be sure. So triangle 1. Triangle 1. So let's pick some points that are easy to read on this triangle. Let's see. I found this one on the corner easy to read, and I think I picked this one here. I know it's hard to see because you can't see the squares behind it, but they really are going down by 2 here. So that's 2 over, and then we're going to the right, 1, 2, 3. Now, down 2, of course, means that I need to put a negative sign here, right? You can tell that that's a negative slope, right? So from here to here, I go down 2. I'll do that again, I'm sorry. From, oops, mouse out of the way. that's getting annoying. From here to here, we go down 2 and right 3, giving us the negative 2/3 slope. Let's try triangle 2. All right, so let's erase this for a second. If you want to just use a different color maybe on yours. I see this point again, of course. I can use that one because that connects triangle 1 and 2. And I can just use this bottom one too. Well, from there to there, I apologize for all the interruptions. We're going to go down 2, right? Down 2, and to the right, 3. So again, down 2, right 3. They both have the same slope. Okay, what is the equation of this line? Well, what do you need for an equation of a line? You know it's this. So I need to find two things. I need to find M and B. Well, let's start with M. Pick 2 points on the line that are easy to read. All right, how about this one maybe, and well, this one's pretty easy. To get from one to the other, I'm always go from left to right. I'm going to go up 1, 2, 3, 4, and right 1. So it's a positive 4 this time over 1. Rise over run. And then the y-intercept is where it hits this y-axis. Where does it hit the y-axis? Well, right here at 0. So we have y equals 4x plus 0, or just y equals 4x. Okay, number 3, what's the equation of this line? Of course, we still need y equals mx plus b. So we need to find m and b. This time the slope, as you can tell, is going downhill. So let's put our negative sign there so we don't forget. Well, let's find 2 points. I see this one. Oh, let's see. I don't think I see another one. Maybe that one's not on. Oh, this one's hard to tell, isn't it? Whew. This one's tricky. I'm going to use this. Say this is on the line. I know the other one looked closer to on the line to me, but I'm going to use that one anyways. I don't like this one. Okay. I'm going to use those 2 points. We're going to go down 3, 1, 2, 3, and right 1, 2, 3, 4. So down 3, right 4. And therefore our y-intercept is where it hits the y-axis, which looks like there, and which is 2. And maybe they weren't going for that, but that's what I'm going to use for my slope and y-intercept. So y equals negative 3/4 x, don't forget your x, plus the 2. Okay. What is the equation of this line? You should know that without having to do anything. When it doesn't have a slope, it doesn't go anywhere. The slope is 0, right? The slope is 0. And the y-intercept is 0. It's just y equals 0. But you should know that it's a hoi. It's a horizontal line with a 0 slope, and it's a y equals a number equation. In this case, y always is 0. You can test yourself on that. This is the point 0, 0. This is the point 1, 0. 2, 0. Oops. 3, 0. Notice y is always 0. Y is always 0.